In my previous video, I showed that the numbers given to us by NASA are incorrect in regards to the speed of the moon and the eclipse of 2017. Please watch that video to get more background information. As I said in that video, the eclipse can only occur when the moon is passing the Earth, creating a shadow on the Earth, as you can see in this clip from NASA. This is a supposed real video of the eclipse shadow passing over the US. A lot of flat Earth researchers started asking the question how the eclipse shadow can move west to east when the Earth rotates east, creating a vector going in the opposite direction. This is what NASA said. Pause the video to read it. Their numbers are for the equator are overly simplified, and they do not show any calculations or explain how they reached the number Mach 1.5, which is 1838 kilometers per hour. These are my numbers from the previous video. However, someone in the comments pointed out a few errors, making my calculations inaccurate. The first error was that I added an Earth radius to the distance to the moon. That was not necessary, as the number given, 384,400 kilometers, was center to center. That would bring the moon speed down from 3,465 kilometers per hour to 3,408 kilometers per hour, 8 kilometers faster than what NASA said. The second error was that I used the total time of the partial eclipse. I should have used the time of the full eclipse, which was only 1.5 hours. More than half the time I had used. That increased the speed of the shadow a lot. The third error was that I used the average speed of the moon across the surface of the Earth. As the Earth is a sphere, the speed varies greatly depending on where on the sphere the shadow falls. In the middle of the sphere, the speed would be close to the linear moon speed, but much faster on the sides. So was NASA correct after all? How do we find the correct speed for the eclipse shadow? I found these numbers on the NASA website. They give the distances between observations at given positions and makes it easy to calculate the actual speed of the shadow, as well as the speed of the Earth's rotation. I created a script and loaded the numbers into this table. The circumference, rotation speed, moon speed, and averages are recorded for each location and printed to the screen. You can find this script on GitHub if you want to play with it. I'll link it in the description. Running the script shows us data for each location and then the totals at the end. We can see that the total time was 1.5 hours, which gives us an eclipse shadow speed of 2,663 kilometers per hour. The total distance was 4,018 kilometers. In NASA's document, however, they didn't even get this right. They said it was 4,019 kilometers. Just 1 kilometer is not much, but since NASA is supposed to be experts as math and science, this is just embarrassing. So far, none of the numbers NASA used make sense. So the total time was 1.51 hours over 4,018 kilometers. Giving us an average speed of the eclipse shadow of 2,663 kilometers per hour. NASA said it should be 1,838 kilometers per hour, which is wrong by 825 kilometers per hour. In this drawing, B is the moon, L is the shadow that it's casting at a given time, and S is the sphere of the imaginary ball Earth. We can find the speed of the shadow on the Earth's surface using this formula. R is the radius of the Earth, x is the distance traveled from the center of the sphere, v object is the speed of the moon. When we have the surface speed, we can use this to calculate the real speed, the speed of the moon across the Earth's diameter. We used this technique in the script to get the moon's average speed, which was constantly higher than what NASA said it should be. The Earth rotation average speed was 1,282 kilometers per hour, with the moon's surface speed across the sphere being 4,005 kilometers per hour, which is the speed of the moon without rotation. The real speed of the moon across the Earth is then 3,846 kilometers per hour, which is 446 kilometers more than the number NASA gave us. To conclude, nothing in NASA's calculations made sense, and this is the first one I've tried. I'm not a math professor, and I'm just doing this because I'm curious. This brings up some questions. Why is no one checking these numbers? Is everyone in the so-called scientific community just zombies? How can NASA and Wikipedia get away with this? Not only was everything wrong, but their errors are huge. The numbers are not even close to making sense. What are astronomy professors doing with their time? Are they so indoctrinated that they don't even think about that NASA can ever be wrong? They are obviously interested in the cosmos, but why aren't they interested in the truth? Based on the work of flat earth researchers everywhere and just common sense, it should be clear that they are not telling us the truth by now. While we are wasting our lives, working jobs we don't want, watching TV and getting drunk, they are laughing at us. How much longer are you going to let them do that? When are you going to get mad?